Pseudocode for activity selection problem. In the last lecture, we learned about activity selection problem and we also learned about the greedy algorithm which can be used to solve activity selection problem. Here, we are going to write a pseudocode for the algorithm that we learned in the last lecture. Pseudocode in the sense we'll be trying to make it as close as possible to the syntax generally used in multiple programming languages, but we won't stick to the syntax of any particular programming language. So we'll try to make it as close as possible to multiple languages so that you can easily convert this by referring to this. You can easily convert this to whichever language you want to code in. So let us start with this. First of all, in the last lecture, we learned about activity selection problem, which is you are given a set of start times and finish times of different activities. And what do you want to do with this? Using these start times and finish times, you want to identify the maximum number of activities that can be chosen such that there is only one person who is doing these activities and this person can do at max one activity at a time. So you want to see how many of these activities can be done by this person at max. This is the task. So the input, let us say, is an array of tuples. So tuples means there will be two values in each index. So let us say index 1 you will have starting time of S1 and F1, that is starting time of first activity and finishing time of first activity. This will be the first index of array. In the second index, you will have starting time of second activity and finishing time of second activity. So similarly, let us say you have n different activities. Considering this, how can you write a pseudocode? Let us write a function in order to solve activity selection problem. Let us say activity selection problem. What is the input? Input is an array. Let us say array. So this array is an array of tuples. Tuple means two entries in each index and those two entries will be starting time and finish time of activities. So what is the first step? As we discussed previously in the last lecture, we discussed that the steps to be followed is first step is sort the given set of start times and finish times according to the finish time of activities. So in the ascending order of finish time, you will be sorting complete set of activities. So after you sort all activities, what is the next thing? You can choose the first activity directly. Why is it? Because there are no dependencies. You can directly choose the first activity because it is having least finish time. After this, for all the remaining activities, you have to check whether the start time of this activity is greater than the finish time of all the previous activities. So if start time of this activity is greater than the finish time of last activity, that means you can go forward with this activity. So in this method, you are going to select all the remaining activities one by one. Let us see how we are writing the pseudocode here. Activity selection problem. Using this array, first step is sort. So sort the array by the finish time. Okay. By the finish time, you're going to sort this array. What is the next step? You want a final selected list. So in that selected list, you will be keeping all the activities which you have selected. So let us call that list as S. This is the selected list. Initially, it will have only one entry. So this is a list in which you will have only one entry, which is AR of 0 for now. So after sorting, you are putting the first element in this selected list. Why are you putting? Because the first element is having the least finish time. So if an activity is having least finish time, there is no other dependency. You can directly pick it in the selected list. After this, you want a variable which will keep track of the finish time of last activity. So let us say last activity's finish time. This is equal to AR of 0 dot, let us say, finish time. So this is giving the finish time of last activity. Last activity means whichever be the last activity you have picked into the selected list. So the point is whichever activity you are going to choose after this should be having a start time which is greater than the finish time of last activity. After this, you can start a loop. Let us say for I is equal to 1 to length of array minus 1. So length of array minus 1 means till the last element of array you are going to run this loop. Inside this loop, what should you do? First thing is, inside this loop you should be having a check which will see whether the start time of this activity is greater than the finish time of previous activity. So if, what should be the check? Let us say array of I dot start time should be greater than or equal to the finish time of last activity, last finish time. So this LFT is the variable in which we are storing the finish time of last activity. So if this condition is satisfied, what will you do? You can append this particular element of array to this selected list. So let us say that selected list dot append. What will you append? You will append this particular element of array AR of I, because it is having a start time greater than or equal to the finish time of last activity. After this, you have to update this variable last finish time. Last finish time. This will be updated to AR of I dot finish time. So this is the new entry for last finish time. So once you do this for each of the element in the array, you know you have gone through all the elements and you have final list in this list called S or selected. So you can return this selected list. This is the algorithm for activity selection problem. In the last lecture, we also discussed about the space and time complexity. We said time complexity is order of n log n. So how is it order of n log n? Because if you see in this algorithm, first step is sort, which takes order of n log n, right? After this, if you see all the remaining step, this is an order of 1 step. Then again assigning to the variable is order of 1. Here you are having a loop which is running through all the elements of the array, which means order of n. So inside this order of n, this is again order of 1 operation. So in total, the largest term is order of n log n, which means the time complexity of this algorithm is order of n log n. And what about the space complexity? You can see in this complete algorithm, you are not using any extra space. That is, constant space is okay. Whatever you are using for these variables, that is called constant space. So space complexity is order of 1. Order of 1 means constant. So the time complexity is order of n log n. Space complexity is order of 1.